So just to recap, metallic bonding is the electrostatic attraction between a lattice of positive and negative ions. You can also get away with positive cations floating around in a sea of electrons. That's also an acceptable explanation. So that means that for the properties, you can see that the electrons are free to travel around in this lattice. And that is a subatomic particle. It's very, very small. And that means, number one, that electricity is free to move through this substance. And it also means that because these particles can move quite freely, it can conduct heat also extremely well. So that is the main difference with metallic bonding. There are very few exceptions to that. Graphite is an exception that has layers. It's a covalent substance that the electrons can move in between the layers. That's an exception of a non-metal electric conductor. Now, another peculiar thing about metals is that because the electrons are freely floating around in this sea, the metal ions themselves can also move over each other relatively easier. And so you can make this into different shapes just by hitting it. And so that's called being malleable. Now, just to go a little bit deeper in the strength of the metallic bonding, if you have, relatively speaking, if you have a similar size cation, the one that has the larger charge will attract the electrons and be stickier. So the substance you can think of as clinging together better, and that'll have the larger metallic bonding. Also, because of the density, if it has the same charge, such as these two cations here, but the smaller cation here will allow them to pack more densely. And so the smaller size of the ion will make a stronger metallic bonding, as will, as I said above, stronger, more positivity. Okay, so more positive and smaller makes for a stronger metallic bond.